Okay, today's algorithm is called DNA pairing. The DNA strand is missing the pairing element. Take each character, get its pair, and return the results as a 2D array. Base pairs are a pair of AT and CG. Match the missing element to the provided character. Return the provided character as the first element in each array. For example, for the input GCG, return this two-dimensional array. So as you can see, every letter comes at first in each array, along with its relevant pair. And the pairs are this one. So C always with G or reverse, and T always with T, and A with T or reverse. The character and its pair are paired up in an array, and all the arrays are grouped into one encapsulating array, so like this one. So these are our four constraints. For the first letter, we return this array, G and C. For C, we return C and G, and for G, G and C. And the same reasoning for the other one. When we speak about A, we need to return A plus T, this one. When we speak about G, return T plus A. C returns C plus G. G returns G plus C, and so on. And the same for the other ones. So how would you construct this algorithm? We have said we need to account for each character. So as you can see, this is a string. So first of all, we need to split it in each character. And then when you have access at each character one at a time, how would you continue? Okay. In the meantime, let's split this string. I was thinking of creating an empty array that will be used as the outer one. So this one and this one. Const outer, outer, empty. Now we need to split this string and loop through it one character at a time. So str, we append a full cycle method that's used for each. Yeah, of course, I forgot to split the string. A step at a time. So console log, I show you what is happening. Okay, node, how do we go? As you can see, the string has been splitted. So now we can work on each character. So now we can append the for loop. It takes an argument. Let's call it element. And here the body of our loop. We've got a couple of cases. So maybe we can use the switch condition. Switch is like if else, but it's more elegant if we need to type down more than two cases. And this is an example of uh, a good suit for switch. So switch as a condition, nothing in particular, but to make the switch stands out, we need to initialize the condition as true. So let's write down true. So we are sure the switch will be carried out. And the syntax is curly braces and case. The case, the case is let's start with G. I want to check out whether the letter is G. Okay, and to do that, I will use a regex. When we speak about characters, strings, regex are always a good choice. So case, the letter is G. I append the test method. It returns a Boolean value, so true or false, upon element. Element is in every cycle a different letter. So in the first cycle will be G, second cycle C, third and last G. For this scenario, of course. In this case, this will be evaluated as truthy. And when it is true, I want to push this letter with its corresponding pair. So I can use the outer array I already initialized, and we append the push method. Push method is used to push, insert an array or an element, whatever we want, inside an array. So inside the outer array, I want to push, insert another array. And this array is composed of G, and the second letter will be C. So when the letter is G, I want to push this array. So in the first letter is G, and this array will be pushed. So let's carry on with the other cases. We need to account for G, A, and T. Um, when we finish out the case in a switch, we need to type break, otherwise it will continue and it won't stop. Okay, second case. We use the same method, the same reasoning, but with a different letter. And this case, C. When we run into C, we push another different array. So outer, push, which kind of array? We have been told if C returns C plus G. C, G, break. Another case, another letter. This time A or T. Outer, push, another array. With T, we need to push the first letter T and the second A. Break. Now, just one more case is left, so we may use the default case. If all of these are not met, then the switch will execute the default case. The default condition is when we speak about A. So outer, push, A, T. Okay, so now this empty array will no longer be empty, but it will be populated with values. So we need to check it out before returning it. Yeah, mind out because you are inside the switch again. Okay. Console log outer. Okay, let's check out. Okay, this one is the outer array, and inside we have got 5 arrays. Yeah, because we've got all the constraints. So this one is this one, and it is functioning, as you can see. ATCGA is this one. ATTACG is functioning. TTGAG TATAGC ATGC. Perfect. CT, CTA, CG, TA, CG, TA, AT. So as you can see, every letter has got its corresponding pairing. And I want to show you the same algorithm in another language. This is Python. This is the syntax to convey the function. This is the syntax to create an object, like, well, in this case we used regular expression. So in this case we are using um, another method, this line, to create an empty array. And this is a for loop, like we did with for each. And it is going to loop through every character like we did in the other one, and we use a list of string, so automatically this string will be divided. And in this case we append upon this empty array at line 5 L, that stands for each letter, along with pair of L, in this case pair of T, sorry, pair of A equals T, pair of T equals A, and so on and so forth. And eventually we return it. This is just to show you that provided you have got a good reasoning capacity to solve every algorithm, it is easy when you want to transliterate it in any languages you want. I may continue with other languages, but I think it is okay. So I hope my explanation was enough clear, and thanks for watching.